Hi everyone, welcome back to my mathematics teaching channel online today. So as I promised, today in our next video, I will show you how to sketch the function based on its derivative. So yesterday we were learning about sketching the derivative graphs, but today we'll go backward, given the function, and we will, given the derivative function, we try to figure out what is our original function from the sketching of derivative graph. So let's take a look at the two graphs on my board right now. And actually, there is a trick to sketch this stuff. When I was in high school, again, I told you the truth that I did not get this topic very well. I felt like, and most teachers went through this very fast too, because it seemed that that's the pattern that nobody want to dig right into the sketching of the graph of derivative, because first of all, there are many other things to learn as well. So sometimes the teacher have to skip through it very fast and just focus on the main idea, the importance. Now, I believe that every details in mathematics is important. It's just like sometimes we have to restrict it. We have to focus on this one and omit the other one and missing. So it's good now the internet provides us free education online. You can pick up from this instructor a little bit, watching another instructor a little bit, get something from someone, get another thing from the other one. And that will help you to have a broad knowledge. And you will see the world in a different perspective, like different teaching style, different learning style, and you adapt yourself with whatever you feel. It's good for your view, it's good for your course, it's good for your learning. So anyway, I try to get into the lesson right now. Okay, so we have two graphs, right? So let's do the first one first. The first one is the easy one. However, remember, this is not the function. So that's why I mark here f prime of x, which is, this is the derivative function. And we, based on this derivative, we sketched our original graph. So do you remember like what kind of graph we're supposed to sketch? If given us the slope of the graph like this, derivative is the slope, right? So what if the slope of my function is this? So what kind of my function? What is my function? What is my graph? Like, you kind of wonder, like, what kind of shape is that, right? Okay, out of the clue. So let's think. This indicates that this is in negative quadrant, right? Negative. From 0 to here is positive y, and from 0 down here is negative y. So we know this is negative. Now, if the slope, the derivative graph in the negative slope, in the negative quadrant, it means this is negative slope. So what happened for negative slope? So if the slope is negative, function f of x is decreasing, right? Not increasing, but decreasing. So the function is decreasing. If the slope is negative, the function is decreasing. So we know that our function is supposed to be decreasing, not increasing. So therefore, we should put in the high level and then go down, right? To a low level. Decrease until the slope equals 0. So we can put our sketching down here, right? So this is our function. It going slow, decreasing, right? Because we have a negative slope, and finally touch the slope equals 0. Now, if you look at this segment of the linear, this is a positive slope for sure. So if the slope is positive, what happens? The f of x will be increasing, opposite, right? So from 0, our slope of this curve will go up, increasing. So that's all you have to do. Now, because on the board, it's hard to see the color, so I come up with original, I leave the f right of x at the solid line, but after I sketch this, and this is the f of x, right? The original function. Then I'm going to delete some part of it, like a broken line instead of a solid line, so that you will figure out, oh, this is the derivative graph with the broken line. And the solid one now is the one we try to sketch, the f of x function. So we're done, the first one. Easy, right? Now let's go to the second one. The second one is a little bit complicated, right? Okay, so if you look at the second one, now to sketch this opposite, this is derivative, right? So to sketch the opposite, remember 3 hints yesterday I told you, first pay attention to their slope points and intersection points, and pay attention to the shape of the curve. Is the function increasing or decreasing? And the third hint I give you, which is if our derivative graph is a degree 4, then our original function have one higher level of degree. So our function will have a degree of 5. If our derivative graph have a degree of 3, x to the power 3 and 3 roots, then our function, original function, will have degree of 4 roots. So that's very much about the polynomial graph, right? We're not talking about any other shape. We're talking about the curvy shape like this. So let's look at this shape, curvy shape, and let's find out how many roots of it have. So this is one root, right? When the curve touching the x-axis, that's we call the root, right? So we have one root here and one root here. So that 1, 2, 3, 4. So our derivative have a 4 root, x to the power 4. Then we know that when we reduce the graph with type of this kind of function, we'll have a 5th degree, right? So let's check how we're going to do that. Now, second thing, we're going to pay attention to the positive and negative slope, right? So at this point, the function on the positive y, right? The derivative y here is on the positive level. So we mark it positive. We mark this from here to here. The function has the slope of the function negative. Then from here to here, positive. From here to here, negative. From here to here, positive. So we pay attention to those things. What else do we supposed to pay attention? We supposed to pay attention where the minimum point, because at this minimum point, we have a slope for our function. This is tangent line, right? For our function, the slope will be equal 0 at this minimum point. At minimum point, the slope here equals 0. The slope of our, the function have a slope of 0 at this point, right? What else? This one as well, m equals 0. Okay, so that's all we need for now. These are the stuff we should pay attention when we start sketching. Later on, what else do we need? I'm going to show you. If you look at this direction, right, of this graph is positive slope. So we know that our function have to be increasing this way. And here, the function have to go through the zero line. So let's say I sketching the curve up here. I can sketch down here, doesn't matter. I can sketch here or up here, but maybe sketch up here, you will see it easier. So I'm going to sketch it up here. So let me mark. So suppose I move my function original graph up here. So my x-axis no longer down here, maybe up here a little bit, right? So I just mark the x-axis as the broken line, right? For my new graph I produce. So I produce the original graph right up before, above the derivative graph, okay? So I know that at this point, my function will have us go through the zero. So I'm going to mark right here. This is zero. My function will go through. And if I sketch the function, this is a positive slope, so function increasing. So go this way, right? Then right here at this point, I know this is the maximum, no, a minimum point, no, maximum. Why? Because I start function go up like this, right? So for sure that where at the point zero here, right, the slope have a zero, then my function will have a maximum horizontal tangent, just like this one here. So I know that at this point, my sketching graph, so my graph is function increasing. So I start from here and go up here, right, increasing. Up to this point, I have a maximum value for my function. Then I know that at this point, my function have to go through this. So it will go down like that, okay? What it happens when you have the horizontal slope on your derivative, we have an inflection point because this is our concave down, right? But then we will transfer to, because the function at this point have a negative slope. So our function will be decreasing. So we transfer from concave down to concave up. So at this point, we have an inflection point, because the transition from the concave down to the concave up, because we have a negative slope, right? So our function have to be decreased. And then at this point, we have a m of 0, which is we have a minimum point right here. So this is minimum, and this is maximum. The reason because we start from here, we start our pen from here to make a function increasing. So therefore we know right here is a maximum value. Maximum value when we have a tangent line at the slope m equals 0, just like the shape down here, right? Because it's similar shape, this is a curved shape, right? So our function have at this 0 of the derivative, we have a maximum maximum right here, and then at the where is that? Okay, we were talking about this is maximum function, and then when the horizontal, when we have a horizontal here tangent, we know that our f(x), this is f(x) function, right? We go to the x-axis at 0 point, right? And now it become, because we have a negative slope, so function decreasing, and then cut at this point, we have a minimum point, right? Minimum for our function. And then here we have a positive slope again, right? It means the function will be increase, and cut through the minimum value which is we'll cut through the 0 again for our function. So at this point, we cut through 0, just like here, right? At this point, we cut through 0. So here at this point, we cut through 0. So now we go up because the positive slope, right? From here to here, still positive slope. So we go up again. And at this point, if it go up, it means we have a maximum value again. So from here to here, right? If I put the ruler, right here we have a maximum value again. Okay? And then, so at 1, we have a maximum value. So after the maximum value, our derivative, which is the slope, negative again. So it means our function go down again because our function will decreasing because the negative slope. And then we have a horizontal line here. It means our function will have to go through the 0 right here as well. So it go to 0, right? Right here, 0. And then here, the function cut through 0. What does that mean? So it means we have a horizontal tangent line again, which is minimum point. So this is minimum. So maximum and then minimum. Minimum right here, right? Minimum right here. So minimum, okay? And then the slope is positive. It means function increasing again. And then keep increasing, right? So here minimum, and then function keep increasing. All right, so that's how we done to sketch the original function based on the derivative function. So I'm gonna broken this graph to make you distinguish. The broken one is a derivative and the original is a solid one, okay? So I'm going to make this broken. So now you know the broken graph is here, is our derivative curve, and this is our function. So this function is function f of x, the solid one. Now let's count how many roots the solid one have. So okay, so let's see. So this is 4 roots, right? 1, 2, 3, 4. Okay, we have to have this for 5 roots. So see, what do I miss? We have 1, 2, 3, 1 root, 2 root, 3 root, 4 root. Do we miss anything? Okay, if we count this one, then we have this is 5th root, but let's see, how do we know that? So we start from, let's go up here. So yes, of course, this line has to be come down here because remember this curve, the way is keep going, right? So this one keep going down and this one keep going up. So yes, it has to be cut through the 0 point here. So we have to count this one. 1, 2, 3, 4, 5. So this is 5 root and more than this 1 root. So I didn't miss anything. This is the shape of our function. Up top here, the original one, and down here, the derivative one. So what do you think? Is it easy or difficult? I don't know. For me, I think this topic is difficult. But anyway, I would like to show you many details in the introduction, first introduction to calculus course as much as I can. because this is the first course I am developing. So I make sure that I cover enough the depth, not rather than just the surface. So I want to do a good job, right? So I cover many details and important things. I think that the most important, right? Now, most teachers in university or in your high school, when teaching you the calculus course, they might touching this topic a little bit like quicker, you know, not demonstrate like so much in detail as I show you here, but some teacher might touch this topic. Maybe another teacher might omit totally, I don't know, right? But this cover in the introduction of the calculus for sure, curriculum. So anyway, so I show you, yesterday I showed you 4 graphs or 5 graphs to sketch from the derivative of the function. Now that seems to be easier than go backward, right? So go backward is more complicated, but I show you 2 of them just for you to get the idea, right? This is my hint to you. When you sketch the graph, you pay attention to the maximum level. So you know that your function, this is the positive slope, so your function increasing. So you sketch like this. And you know it had to go to maximum level because the root here, the 0 here. At here, you have a tangent as 0, right? Maximum level. And then at the minimum level of your derivative, it means your function will cut through the 0 on the axis. And then here, if it cut through and it's still function still negative, so your function still going down, it means you have to hit the minimum level at this point, right? You cannot have a maximum because your function going down, so you hit the minimum level. And then at this point, your derivative have a slope of 0 tangent. I mean, you know that your function have to cut through the 0 line. And then go up here, your function as the maximum level again, because here you have a positive slope, right? It's on the positive section, so your function will be increasing, right? Because positive slope, so your function, look at the side, right? Your function increasing, and up here, you have to go through the maximum level because increasing, then you have to stop right at the maximum level right here. And then, you know, here you have another tangent from derivative, so you know your function will cut through 0 again. And then, you know, this is negative slope, so your function have to be decreasing. And here you will have to hit the minimum level, right? At this point, you have to hit the minimum level because your function decreasing. So now here your function is increasing, so it have to go up and increasing. And I'm talking about this part, the reason like before we put the pen up here, but we realize that this is a wave curve, it keep going. If this like this, it means it have to cut through the line. So therefore, we have counted 1 root, 2 root, 3 root, 4 root, 5 roots. So 5 roots, so therefore at higher level than this is 4 roots. So we make sure that our sketching is accurate. It's the shape of original function based on the derivative function. So I hope that you enjoy the sketching. Stay away from on the writing and knows the calculation. So now let me focus on the next bar. So let's go through the next bar. So what do I show you for the next bar? So this is another question might appear in your course, right? Something like this. Given f of 2 equal f of 4 equals 0. F of 3 is defined. F prime of x is less than 0, which is negative. If x less than 3, f prime of x bigger than 0 if x bigger than 3. F prime of 3 does not exist. F 2 prime is the 2 prime here stands for second derivative. So in the future, if you learn second derivative is is not a big deal because the same like the first derivative. So you take derivative of the first time, then you take one more derivative of the second times. After you apply on the chain rule, the power rule, and you take the derivative of your function the first time. So we call it first derivative. So what you have learned so far with me in this course is we're talking about the first derivative. I haven't had a chance to mention about second derivative, but the performance, the rules is exactly the same. So if you learn the first derivative, for you to take the second derivative, nothing is more difficult. You perform the same rules, the same step, right? So I don't even have to mention, but in the future, I will give you some example with the second derivative in there, and you will see how we do it, because exactly the same, nothing changed. So why I bother to teach twice, right? So when you learn the first derivative, you already know how to do second derivative. And the second derivative help you to figure out whether your function have a concave down like this, right? We call it concave down. Concave down, right? Whether it's a full piece like this or just half piece like that, that's concave down. This will be concave up. This we call concave up. And when we're talking about the shape of the function, concave down, concave up, we're talking about the second derivative. The second derivative, if your second derivative is negative, less than 0, then you have a concave down. If your second derivative here, 2 prime here, right, instead of 1 prime, it's 2 prime here, is positive, bigger than 0, then your shape of the function will have a concave up. So that's on, and that will help you to sketch the function more easily. That's it, okay? So let's see how we apply all of this into our graph. The question says sketch the graph, right? So we have to sketch the graph based on the information they give you like that. So let's check. So on the graph, we know that they told you that we have f of 2 equal f of 4. And f of 2, it means the x here, right? Because this is f of x, right? So the x here is in value 2. So at 2 will be equal 4, at x is 4 equals 0. And the 0 here is the y value, right? So this point actually is 0, 2. And another point is, 2, 0, 2, 0, and another point is 4, 0. It means the y value, right? Because this is function f of x, so the y value is 0. So now we know that the y value is 0 at x equal 2, so we mark that. That's the root of function actually. The function will cut through this point. And the y here is 0, right? This point like 4 and 0. Right, the same like this one. And that's based on the first information. We mark these 2 points. They say that f3 is defined. So we know that f of 3, which is at this point, our function will be exited. But how it exists, we don't know, right? We have to read more the information and see. So it says f3 is defined. F prime of x less than 0, which is our derivative function, which is the slope of our function, will be negative, right? The slope is negative if x less than 3. So from this point, x, all the way to this side, our function for sure is a decreasing shape like this, right? Decreasing shape. Because they say that the slope is negative. When we have slope is negative, right? Like this, our function is decreasing, right? So we know it has to go not this way, but it goes this way, right? So we say from here, from this point forward, our function is, slope is negative, so our function is negative, okay? Let's just read it first, and then we try to think about general shape before we put our pen in here, okay? So f right of 3 is does not exist. So we know right here, the derivative does not exist. So what does that mean? What does that tell you? If right here the derivative does not exist, we might have a tangent, right? Vertical line tangent like that, and then a broken derivative, or we might have a sharp point turn right here, right? If we have a function, we might have a sharp point turn somewhere like that, okay? So that is the two scenario for the f right of 3, which is derivative 3 does not exist. So whether we have a sharp point right here, maybe the shape like this, or might be like this, right? That is the case because they say derivative right here does not exist, right? So we think about that, the general thing, right? Okay. F right of x. So now we pay attention to second derivative fx, f right of x. I just told you if it's negative, we have a concave down. So concave down, it means this shape or this shape, right? Because of this right here. And they say that f right of x have the derivative have a positive slope if x bigger than 3. So from this 3 forward this way, our function will be increasing, right? Our function increasing. And x, the condition x have to be different from 3. Of course, if the derivative is not exist here, it means that the x have to be different from 3, right? The x have to be different from 3. It means we cannot have an x right here, right? So we might have an x, we might have an x somewhere because it say f of 3, f prime of 3 does not exist, but f of 3 is defined. It means at x equal 3, we might have a function somewhere here, or down here and here, as long as, because f of 3 have to be defined. But as long as the value of x is not 3, so it means for sure we don't have a point at 3 and y something. We don't have something like that. Okay, so that's how we figured out right now. So how are we going to sketch this function? So we pay attention from here to here. We have a function is decreasing, right? Which is our shape of function have to be like this. So let's get something. And have to go to our function, have to go to the root here because it's a f2 and f4 equals 0. So maybe something like this, right? Like a concave down, right? And it say, so concave down, because this, right, concave down, and f prime of x is negative, so our function is actually, wait a minute, from 3, x less than 3, f prime of x is less than 0, which is our function, no, it cannot go this way. It has to go this way. Right? You have to go this way because they say from 3 over, the x have to be decreasing and it concave down. Concave down because from here to here to here, function f prime of x is negative, so function decreasing. and from here to here. So it goes this way, and it goes to 2, the function decreasing, and then from 3 to function increasing. So we have concave down, because less than 0, we have a concave. That would be concave up. That doesn't make sense. Okay. F prime of x less than 0. Okay, so if we figure out like this, then yes, this is function go to 2, and it's a concave down, right? And concave down go to 2, and function decreasing. So our sketch look like this, right? Okay. Now it say f prime of x will be bigger than 3, will be increasing. So I have to cut through this. So now we have a concave. F prime of x, so function increasing, right? Function increasing, and f prime of x, the slope is bigger than 0. So our slope is positive, it means our function increasing. And somewhere at 3, we have a pointed shaft like this, right? So yes, and you can see the shape of this one is concave down, which is satisfy this condition, right? You see the concave down curve. Okay, and this also concave down, but we don't mind about that. We don't care about that. This is satisfied our sketching right here. The reason because we have f prime of 3 does not exist. And you remember when we have a sharp point here, we cannot have a tangent line like that. So does not exist as x equals 3. However, f3 is defined. So if we go back here, yes, we have a point here. So let's say the y value here is -2 something, then yes, the f of 3 is defined. And we have the function decreasing, right? Decreasing because f prime of x is negative, the slope of it negative. So this is how we base on the information and we sketch our curve. So I hope you, at this point today, that's all I can give you for this video. And I hope you enjoy it. We'll see you in the next video. In the next video, I probably get into the trigonometric derivative and logarithmic derivative, or maybe I can pass it and we see it in the future, but we get into the application of derivative. Maybe that part is more interesting, and we get back to the logarithmic derivative, trigonometric derivative more in the future. Okay, so I like to show you something useful in calculus, right? So maybe I should get right into the application of derivative, how you solve the word problem in the next video. So let's see how it's going. But I hope you enjoy the sequence of my teaching mathematics based on the first introduction to calculus course. And this offer you online. You can watch from YouTube. You also can register to my course Developing Online. When I finish, I publish, I hope that I will have more and more audience support me. You get into my course online, register and learning more thoroughly if you need it for your future. So thank you for watching and bye for now.